Hello students, welcome to the lecture on basic architectural concepts, and after the lecture we will be able to learn the following objectives. Explain the basic architectural concept, describe the entire architecture design approach, understand system control interfaces, describe the architecture for multi-user interfaces. Let's start with the introduction. The architecture has many different phases. Not only is it functional, but it is also artistic, mathematical and scientific. If they are studying architecture or already an accomplished architects, surely are familiar with some of the most basic and important architectural concepts. Some of these concepts are proper use of space and light. When we demonstrate these architectural concepts in work, it will find that it is received better by audience. People feel more comfortable in a space that has been precisely and carefully engineered. As we strive to increase understanding of architectural concept, it can be helpful to read several periodicals or magazines. In the modern world, it can also find great information on the advances that have been made in field by following the blogs or website hosted by other architects. Because computers have become such an integral part of society, architecture has changed a great deal. It can now use 3D renderings of architecture. This technology allows of a building before it has even been built. With all of the modern advances that are available, understanding the design process is easier and basic concepts are more accessible. By taking time to study these things, it will be much more effective and successful in projects and its work with other people. Let us now learn about the basic architectural concepts. Architectural artifacts are created in order to describe a system, solution, or state of the enterprise. The notation used is from the Unified Modeling Language UML specification. A system is a collection of components organized to accomplish a specific function or set of functions. The architecture of a system is the system's fundamental organization embodied in its components, their relationship to each other and to environment, and the principles guiding its design and evolution. An architecture description is a collection of artifacts that document architecture. In the Open Group Architecture Framework, TOGAF, architecture views are the key artifacts in the architecture description. Stakeholders are people who have key roles in or corners about the system, for example, as user developers or managers. Different stakeholders with different roles in the system will have different concerns. Stakeholders can be individuals, teams, or organizations, or classes thereof. Concerns are the key interests that are crucially important to the stakeholders in the system and determine the acceptability of the system. Concerns may pertain to any aspect of the system functioning, development, or operation, including considerations such as performance, reliability, security, distribution, and resolvability. A view is a representation of a whole system from the perspective of a related set of concerns. In capturing or representing the design of system architecture, the architect will typically create one or more architecture module, possibly using different tools. A view will comprise selected parts of one or more models chosen so as to demonstrate to a particular stakeholder or group of stakeholders that their concerns are being adequately addressed in the design of the system architecture. A viewpoint defines the perspective from which a view is taken. More specifically, a viewpoint defines how to construct and use a view by means of an appropriate schema or template, information that should appear in the view, the modeling techniques for expressing and analyzing the information, and a rationale for these choices, example by describing the purpose and intended audience of the view. Did you know? Every view has an associated viewpoint that describes it at least implicitly. ISO IEC 42010-2007 encourages architects to define viewpoints explicitly. The ERP applications are most commonly deployed in a distributed and often widely dispersed manner. While the servers may be centralized, the clients are usually spread to multiple locations throughout the enterprise. Generally, there are three functional areas of responsibility that is distributed among the servers and the clients. First, there is a database component, the central repository for all of the data that is transferred to and from the clients. Then, of course, the clients here raw data gets imputed, requests for information are submitted, and the data satisfying these requests is presented. Lastly, we have the application component that acts as the intermediary between the client and the database.
What is an ERP software? How does it work? It is a computer application that manages all the tangible, financial, human assets of a company. It also documents and tracks all the operations of a company, for example, sales and purchasing operations. What is the criteria for an ERP system? It usually has a lot of criteria, but for the sake of simplicity, we will deal with the most important ones. Namely, it should operate in real time. It should have one database which is accessed by the users in different departments of a company. All the different functions provided by the application should have the same consistent look and feel so as to make the user comfortable with the application. Now that we have a brief overview of what an ERP application does, let us look at the different modules it should have. The different kind of modules are sales, finance, customer relationship management, supplier relationship management, purchasing, inventory, manufacturing. Apart from this, reporting is also a very important part. One should be able to look at the health of a company, the sales, costs in a financial year, and so on and so forth. Some commercial examples of a company are SAP, which has the dominant market share in an ERP market. It is produced by SAP AG, which is a German firm. Oracle Financials is produced by Oracle. It's namely new in the market, but at the same time it is gaining market share. PeopleSoft is an ERP system which is solely based on human resources. Now that we have looked at the different examples and what an ERP system should be, let us look at the basics of an ERP architecture. For small-scale systems, we generally have a server which does the job of web pages, at the same time crunching the business logic and storing data. Now, if we try to separate all those three, like web server will serve out the web pages, the application server will just crunch the business logic, and the database server will pretty much hold data, then we have an architecture which kind of looks like what is presented on the screen. Now you might be thinking in your mind, why put it on three different servers if you can put it in a single server? I have only one word for that. It is called scalability. For example, if you look at Walmart, which generates billions of transactions in a single day, the chances are that a single server will not suffice. So we have to break it up into different servers so that it can handle the load and give answers in real time. Again, each of these separate stages, like the web server, the application server, and database server, could be one server, or it could be multiple servers at the same stage. For example, if we have a cluster of servers for the web server, like a site for Amazon.com which has 200 users at one time, then they generally use a software which is called load balancing, which kind of will say, okay, 50 requests go to server 1, 50 requests go to server 2, 50 requests go to server 3, and another last 50 requests go to server 4. It kind of helps to distribute the load so that none of the servers are overloaded and their customers are kind of happy with the real-time performance of the data.
Where these components physically reside and how the processes get distributed will vary somewhat from one implementation to the next. The two most commonly implemented architectures are outlined. In typical two-tier architecture, the server handles both application and database duties. The clients are responsible for presenting the data and passing user input back to the server. While there may be multiple servers and the clients may be distributed across several types of local, While there may be multiple servers and the clients may be distributed across several types of local and wide area links, this distribution of processing responsibilities remains the same. A two-tier ERP approach can provide the ideal combination of global processes, lower cost, flexible deployment, agile customization, and ease of use. Such an approach is useful, for example, for quickly providing ERP capabilities to a newly acquired or growing business, a spin-off, or the entire enterprise during an ERP transition. This fulfills the needs of enterprises that must protect existing ERP investment while obtaining significant new value via cloud ERP extensions. The role of two-tier ERP. Single-instance ERP systems are overly expensive and take too long to deploy to keep pace with changing business models, competitive pressures, regulatory needs, and global customer demands. As single-instance on-premise ERP system age, managing and tracking required changes poses significant challenges to business and IT operation. Unmanaged change requires the IT team to create quick fix patches or deploy point solution to plug potential gaps. All this adds to the very chaos that organizations seek to avoid by adopting ERP. Even after deploying the on-premise ERP system, the core IT team is so busy mending and tucking that they have little or no bandwidth to roll out the system to new subsidiaries, divisions, or processes. A two-tier ERP approach helps organizations swiftly deploy and integrate new processing capabilities at subsidiaries or smaller business units that can be seamlessly integrated into the core on-premise ERP backbone. This approach significantly reduces the time and cost required to implement, support, and maintain ERP capabilities. Two-tier ERP does not replace on-premise ERP, but instead complements it with more agile, flexible, and lower-cost cloud-based ERP. On-premise ERP still provides the standardization and consistency for back-office systems of record for processes such as make to deliver and record to report that are vital for efficient operation, regulatory and legal compliance, and consistent quality. How two-tier ERP helps the bottom line. A two-tier ERP strategy can help companies overcome key technology challenges such as application modernization. Enterprises considering an application modernization strategy can use two-tier ERP to continue operating efficiently while adapting to rapidly changing business needs. Application rationalization. Organization can deploy on-premise ERP to support core corporate function while deploying cloud ERP for market-facing functionalities. New application requirements. Cloud ERP can complement on-premise ERP with next-generation disruptive technologies such as web services and process integration libraries to enable applications that operate anywhere, anytime. Cost reduction. Cloud ERP shifts responsibility from the customer to the vendor for upgrades, patches, and other functions. Cloud ERP also reduces total cost of ownership by eliminating the need to purchase servers, storage, and network capability for on-premise system. Corporate strategies as well as organization and operating models all play a role in determining when and how to adopt a two-tier ERP model. In three-tier architectures, the database and application functions are separated. This is very typical of large production ERP deployment. In this scenario, satisfying client requests requires two or more network connections. Initially, the client establishes communication with the application server. The application server then creates a second connection to the database server. This involves one more layer called the business logic tier, service tier, or middle tier layer. In the client-server solution, the client was handling the business logic, and that makes the client thick. A thick client means that it requires heavy traffic with the server, thus making it difficult to use over slower network connection like internet and wireless, LTE, 3G, or Wi-Fi. By introducing the middle layer, the client is only handling presentation logic. This means that only little communication is needed between the client and the middle tier, making the client thin or thinner. An example of a thin client is an internet browser that allows seeing and providing information fast and almost with no delay. Business systems have gone through some major changes as application development evolved into distributed systems with increasing implementation, complexities, communication across the globe, frequent application changes and rapid pace of deployment. Business needs now demand enterprise-wide business systems that can integrate seamlessly with each other. High-quality service in the terms of infrastructure, scalability, manageability, and availability provides an edge in the competitive market in this scenario. Entire distributed architecture was used quite often for its benefits in the world of fast-changing requirements. This covers the evolution of an entire architecture and discusses its suitability for the ever-growing complex applications that have good maintainability and extensibility as one of their prime requirements. An overview of frameworks and the standards like .NET, J2EE, SOAP is given towards the end, highlighting their role in the entire architecture. Presentation tier. This is the topmost level of the application. The presentation layer provides the application's user interface UI. Typically, this involves the use of graphical user interface for smart client interaction and web-based technologies for browser-based interaction. The presentation tier displays information related to such services as browsing, merchandise, purchasing, and shopping cart contents. It communicates with other tiers by outputting results to the browser or client tier and all other tiers in the network. Logic tier. It is called also business logic, data access tier or middle tier. The logic tier is pulled out from the presentation tier and as its own layer it controls an application functionality by performing detailed processing. Logic tier is where mission critical business problems are solved. Data tier. This tier consists of database service is the actual DBMS access layer. It can be accessed through the business services layer and on occasion by the user services layer. Here information is stored and retrieved. This tier keeps data neutral and independent from application servers or business logic. Components interconnections. It is characterized by the functional decomposition of application service components and their distributed deployment, providing improved scalability, availability, manageability, and resource utilization. During an application's life cycle, the three-tier approach provides benefits such as reusability, flexibility, manageability, maintainability, and scalability. Each tier is completely independent from all other tiers except for those immediately above and below it. It can share and reuse the components and services created and can distribute them across a network of computers as needed. It can divide large and complex projects into simpler projects and assign them to different programmers or programming teams. We can also deploy components and services on a server to help keep up with changes and redeploy them as growth of the application user, base data, and transaction volume increases. The main benefits of the three-tier architectural style are maintainability. Because each tier is independent of the other tiers, updates or changes can be carried out without affecting the application as a whole. Scalability. Because tiers are based on the deployment of layers, scaling out an application is reasonably straightforward. Flexibility. Because each tier can be managed or scaled independently, flexibility is increased. Availability. Application can exploit the modular architecture of an enabling system using easily scalable components, which increases availability. There are some facts about the entire architecture that should be kept in mind before deciding for this architecture for an application. It normally takes more time to develop. Number of tiers should be decided in accordance. The level of interaction between different tiers and between components within a tier increases the path of communication, which may affect response time. At the same time, capability of the same application to distribute itself on different processing machines helps make the best use of processing power. Design starts by identifying and demarcating different application tiers and their functionality. if there are multiple components within each tire. Functionality for each component is identified thereafter. Provision for enhancement and maintainability is to be kept in mind with each design decision. Interfacing between the components and tires of the system becomes very important in a distributed architecture. An attempt is made that interfaces take minimum impact for any design change. Their thoughtful design provides a good foundation to the system for future enhancement. Components can expose its functionality to other components through one or more interfaces. Callback interfaces, a kind of interface, can be used for passing notification from server to subscribed clients. Moving on to another topic, the system control interfaces. Ensuring compatibility among subsystems being designed and fabricated at location throughout the world poses challenges in managing the multitude of interfaces which exist. To aid in managing this geographically diverse work, a formal interface control system has been set up. There were several steps in this process: rationalization for subsystem breakdown, organization of subsystem and interfaces, database tool for tracking interfaces. The subsystem breakdown generally follows subcontract or work package boundaries. Some of the interfaces resulting from this guideline cross Gemini grouped boundaries, some are contained within. Both are to be defined in the interface control documents and drawings, but the priority is placed upon interfaces which cross group boundaries. To identify the interfaces between each of these subsystems, a graphical representation of the subsystem and interfaces was generated in the form of a modified N2 chart. Did you know? A historical perspective, the three-tier architecture concept emerged in the 1990s from observation of distributed system, example web application, where the client, middleware and data tiers ran on physically separate platforms. Using task model as basic for the development of user interfaces is chosen as the approach for the future user interface development and routine environment for ERP system at Bond. Since communication via computer system is and will always be an important part of daily life, we need to incorporate computer-supported cooperative work (CSCW) features into this environment. We discussed the architecture for the task modeling environment and the implication of incorporating CSCW characteristic for this architecture. Generating user interfaces for a single user. A user interface of ERP system consists of both interaction semantics and a graphical presentation, which are independent elements. Example, the button appearance can change independently from the structure of a dialog. Next to the user interface, there is also application logic captured in business object. In the ERP application domain, there is a strong requirement that the application can be customized to specific business and user needs. Therefore, the presentation and the interaction semantics must be customizable in a separate manner. At Barn is chosen for the task modeling approach, Concur task tree notation of CNUCE as basic for the development of a user interface development and runtime environment in order to fulfill the separation requirements of presentation, interaction semantics and application logic. At runtime, the UI and the business objects are coupled to each other via the task interpreter, which connects actions of the user to actions of the application logic and vice versa. Multi-user interface architecture. The task modeling environment must be made suitable for multiple users cooperating on shared objects. In continuation of the separation of interaction semantics, presentation and application logic, the cooperation features should be captured in a separate layer in the task modeling architecture. Based on the thesis of Brindley-Smith, we identified the need of three models to support cooperation in the architecture: access control, policy notes, and roles. Access control. In the access control editor, one can indicate whether a task may be shared and if so, how it is shared, editable or output only. These sharing properties have direct consequences on the user interface presentation of the different user. If, for example, one user has access to all the information of a task and the other user can access only a part of this information, the user interfaces are not similar. Policy notes. Next to presentation issues, also the interaction with the application contains cooperative aspect. The question is, what to do when multiple people are triggering one method? In such a case, the input of the user must be interpreted before a method in the application logic can be called. An example is a situation where multiple users can vote for one certain type of pizza to be ordered. Depending on what the majority chooses, the correct type of pizza will be ordered. Now in the end, let us summarize what we have learned in this lesson. Architectural artifacts are created in order to describe a system, solution, or state of the enterprise. An architecture description is a collection of artifacts that document architecture. In TOGAF, architecture views are the key artifacts in an architecture description. Business systems have gone through some major changes as application development evolved into distributed systems with increasing implementation complexities, communication across the globe, frequent application changes, and rapid pace of deployment. It is characterized by the functional decomposition of applications, service components, and their distributed deployment, providing improved scalability, availability, manageability, and resource utilization. The initialization sequence during system startup needs to be governed. Whole systems should not collapse if there is a runtime error in one of the many components.